All right, Patriots, let's move on to lesson 7-3, solving systems using elimination. Now, when we say elimination, what we mean is we're going to actually be causing one of the variables in our equations to be completely eliminated or to be just kind of wiped out and be able to use that process in order to solve for the remaining variable. Now, this is a very kind of niche type of solution. Things have to be set up exactly right for this whole thing to work. You'll notice as we look down on all of these equations, every single equation that we have on this entire sheet, all 16 of them, are already in standard form. So in order for this to work, you need both equations in standard form, which remember that is ax plus by equals c. And there are ways of doing elimination if it's not in that form, that they revolve around putting them in standard form first, but we're not going to mess with that. We're just going to assume that they're in standard form. If they're not in standard form, you'd be better served by using substitution, but like I said, we're not going to cover that. So we're assuming up front that both equations are already in standard form. Now, our steps here, also realize step 1, you're only going to see this on problem 7 and 8 today. Most of ours are already set up, so you don't need to do this. And this is the kind of extra step that's the more complex of them. So the vast majority of it is set up, so you don't need it. So step 1, you're only going to need on the last 2 problems we do. Okay, so what you're going to do for step 1, if needed, is multiply one equation by a constant to make a variable in both equations have the same coefficient. Okay, that's a lot. Go ahead and pause the video if you need to finish copying that down. But let me go ahead and show you what that means. And why you're not going to need it in the vast majority of these. You'll notice in problem number 1, here you've got a -2 and a +2 on the y. Okay, they have the same coefficient. Well, when I say coefficient, I'm talking about just the number, not the sign. We'll handle that sign in a minute. But I've got a 2 and a 2. Here I've got on the x's, this in the wrong order, but 1 and -1. Okay, on number 3, again, I've got the 2 and the -2. Here I've got the 1 and the 1. Here I've got the 1 and the 1. Here I've got the 3 and the 3, the 4 and the 4. They're matching is my point here. But down here you get to 7 and 8, those last two. Notice I've got a 3 and a 2 and a 4 and a 1. They don't match. Here I've got a 5 and a 1 and a 2 and a 7. They don't match. So those are the only types of problems you're going to have to deal with that on. You're not going to have to deal with that on 1 through 6. Okay, we do that quite a bit in our Algebra 2 application of elimination. We're doing solving systems there. I want you to be exposed to it. We're not going to do too much with it. Also on the assignment, you're not going to have to do step 1 on any of the assignments. I'm sorry, any of the problems on today's assignment. Okay, so now step 2, we are going to add or subtract the equations to eliminate a variable, and that'll make sense. Step 2 is actually why this is called elimination. And then step 3, we're going to solve. And then step 4, we're going to substitute and solve for the second variable. Okay, so let's talk about what those steps 2 through 4 mean. Now, I'm looking at number 1, and I could see that, again, my -2 and my +2 are the same coefficient but with different signs. Now, if I was to add these two equations together, well, 5x plus 3x is 8x. -2y plus 2y, those cancel out. And then 24 plus 24 is 48. Now, that sounds like that's crazy to do, but that's actually a valid, mathematically legitimate way of solving a system of equations, because the two, or both of the y's, eliminated each other, and now I'm left with one equation with one variable. I can now just go through and divide by 8, which, by the way, was at step 3 earlier, solve, and that gives me x equals 48 divided by 8 is 4.5. Oh, not 4.5, 5.5. Just to be sure, because I am not having a good mental math day. 48 divided by 8. Wow, I'm not smart. That is 6. Okay. I'm glad I checked. Okay, x equals 6. Okay, so now the last step, we're going to substitute in and solve. Now, pick one of the original two equations. It doesn't matter which one. I like the bottom one, and there's no reason why. I just picked it. So then I'm going to substitute in. So 3x, and instead of x, I'm going to write my 6 plus 2y equals 24. And now let's go ahead and solve. 3 times 6 is 18 plus 2y equals 24. Subtract 18 on both sides. 2y is equal to 24 minus 18 is 6. Divide by 2, and that gives me y equals 3. So my answer here is just x equals 6, y equals 3. And just like we've done on previous lessons, you could always write it as the coordinate pair 6, 3. Okay, so there's my elimination process. Let's go ahead and look at number 2. Now, I'm going to have to rewrite this one because remember how I said we're assuming this is in standard form. This one right here is not exactly in standard form because the x comes second. So we're going to need to rewrite that. X plus 3y is equal to -7. And then negative x plus 2y is equal to -8. Now that we got standard form, now we can move on with life. Okay, I'm going to add these together. The reason I'm adding them together is because positive x plus negative x cancels out. 3y plus 2y is 5y, and -7 plus -8 is -15. Okay, now let's divide both sides by 5, and that leaves me with y is equal to -3. Okay, so step 4, substitute back in and solve. Pick an equation, doesn't matter which one. Last time I picked the top one or the bottom one, so this time I'll pick the top one. X plus 3y equals -7. I'm going to substitute in that -3. And that leaves me with x, 3 times -3 is -9 equals -7. Now let's add 9 on both sides, and that leaves me with x is equal to -7 plus 9 is +2. So my answer here, x, I need to do that in black, x equals 2, y equals -3, or again, you could write it in a coordinate pair. Okay, number 3, standard form on both, so I can go ahead and move on. Excuse me. So this time, let's see, adding 2 and -2, yep, add those two together. 5x plus x is 6x. 2y minus 2y, those cancel out. And that equals 1 plus 17 is 18. So my y's eliminated. Now let's divide both sides by 6, and that's going to give me x equals 3. Okay, now let's go ahead and substitute into, let's take the top equation, 5, and then x is 3 plus 2y equals 1. Let's simplify down. 5 times 3 is 15 plus 2y equals 1. Let's subtract 15 on both sides, and that gives me 2y equals 1 minus 15 is negative 14. And I'm running out of room here, but I would divide both sides by 2. Negative 14 divided by 2 gives me y equals negative 7. So my answer here, x equals 3, y equals negative 7. Okay, number 4 is going to act a little bit different than the ones before. You'll notice that step 2 here said add or subtract. Now, the reason that's there is because you'll notice that on these, if I was to add the equations together, x plus x is 2x, 3y plus 2y is 5y, nothing eliminates. But I always have the ability to subtract the equations together, and the same process will still work. So here, x minus x, those would eliminate. Now, 3y minus 2y is just y, and negative 7 minus negative 8 makes that a plus 8. Negative 7 plus 8 is 1. So you got to be careful with your signs when you do this. Now, one way of making sure that works out all the way through is that, remember, when you subtract something, you're essentially just distributing a negative sign. So that would make this be a plus, negative, negative, plus. So change all the signs, and again, those cancel out. That still gives me a positive y, and that gives me a positive, or I'm sorry, yes, a positive 1. Okay, now we're going to go through and substitute into one of the equations. Again, it doesn't matter which one. X plus 3 times y equals negative 7, choosing the top equation. Let's go ahead and do our solving steps. 3 times 1 is 3, so x plus 3 equals negative 7. Now we're going to subtract 3, and that gives me x equals negative 10. So my answer, x equals negative 10, y equals 1. Now, I know that was kind of fast. Let's go ahead and run through that again with number 5. You'll notice again, y and y both have a positive coefficient. So since they have the same coefficient, I am going to subtract the bottom equation and not add it. Now, when I do that, what I'm doing is distributing the negative sign. So that's a minus, minus, plus. So now 3x plus 2x is just x. Y minus y, those cancel out, equals negative 26 plus 19 is negative 7. Now pick one of the top two equations. I'm going to do the top one. 3x plus y equals negative 26. We're going to substitute in the negative 7 there. 3 times negative 7 is negative 21, plus y equals negative 26. Now we're going to add 21 to both sides, and that leaves me with y equals, what did I do there? Plus 21. So negative 26 plus 21 is negative 5. So my answer here, x equals negative 7, y equals negative 5. Okay, number 6. I've got 3x and 4y. Let's see, I'm going to have to subtract again here. So I'm going to subtract the equations, which means I'm going to distribute the negative sign. And now 3x minus 3x, those cancel out. 4y minus 4y, both of those cancel out. And then 9 minus 15 is negative 6. Now, don't let this trip you up. This looks kind of weird at first, but realize when two things cancel out, it leaves you with a 0. So what I've literally got here is just 0 equals negative 6. Now, this is one of our special cases like we saw back in first semester and like we saw with the lines back in Unit 1. Remember, anytime that all the variables go away, you got your two options. It's either infinitely many solutions or no solutions. And the way you evaluate it is it true? Well, is 0 equal to -6? No. That is false. Therefore, there are no solutions. Or I could use the no solution symbol. If it had been true, it would be infinitely many solutions. Okay, number 7. Again, we're not going to solve these, but we're going to take care of that very first step that we had said we're not going to use very often. Again, you'll notice that there are no variables, neither the x nor the y, have the common coefficient. So we're going to have to set that up. Now, I could choose several different options of going here, but I'm going to go with the simplest one. Is there a number that I can multiply? Let's just pick out the bottom equation in order to make one of the coefficients or one of the variables have matching coefficients. Well, I see a 4 and I see a 1 right here. So what that tells me is if I multiply 1 by 4, I get a 4. So I can multiply the entire equation by 4, and that would leave me with 8x plus 4y is equal to 12. Because remember, I got to distribute the 4 across all of them. And now I could subtract the 4 or the two equations, and the 4y and the 4y cancel out. So I could multiply the bottom equation by 4. Okay, I'm not actually going to do that right now, but I just want to bring up the idea that you could do it if you needed to. Okay, now looking at number 8, same idea. Here I've got 2 and 7, and here I've got 5, and then there's my hidden 1 right there. What could I multiply by? Well, if I multiply the bottom equation by 5, then 5 times 1x is 5x. 5 times -7 is -35y equals 5 times -63 is a lot. Maybe I'm going to try and do that in my head. 5, 315, so -315. But the point is that here I've got the 5 and the 5, and so I could then just subtract the equations. So I can multiply the bottom equation by 5. Okay, that's all we got for you today. Good luck on the assignment. As always, feel free to reach out if you have any questions.